Factors. In this chapter, we're going to look at factors. A factor is a number that can divide another number without any remainder. Now, before we look at factors, I'm going to explain some things you need to know about numbers. There are various types of numbers, and we already know some of them. First, they are called even numbers. You have odd numbers. You also have prime numbers. So let's start with even numbers. Even numbers are numbers that are multiples of 2. So you have 2, 4, 6, 8, 10, 12, 14, 16, and so on and so forth. Now odd numbers are other numbers outside this. So you have 1, 3, 5, 7, 9, 11, 13, 15, 17, etc. Okay? Now on the other hand, prime numbers are numbers that can only be divided by itself and 1. No other number can divide them. Now the first prime number is 1. Can only be divided by itself, 1 and also 1. 3, 5, 7, 9 is not a prime number. It can be divided by 3, so it's not a prime number. 11 is a prime number, 13 is a prime number, 17 is a prime number, 19 is a prime number, 23 is a prime number, and so on and so forth. So these are prime numbers. Now factors. Factors are numbers that can divide another number without a remainder. Now before now, our division, when we come to division, one will say 4 divided by 2. Our answer is 2. 5 divided by 2. Now what we do here is 5 divided by 2, so it won't go. Okay? Now let's progressively remove a 1. When you remove 1 from 5, what you have is 4. Okay, so you now do 4 divided by 2. It gives you 2. So you now write 2 remainder 1, the one you removed initially. Now 7 divided by 2. When you remove a 1 from 7, we have 6 left. So 6 divided by 2 is 3. 3 remainder the one you removed. Let's take another example. 10 divided by 3. It won't go, so remove a 1 from 10 and gives us 9. 9 divided by 3 will give us 3. So say 3 remainder 1. 11 divided by 3. It won't go. Remove a 1 and gives us 10 divided by 3. It won't go. Remove another 1 from it. And now 9 divided by 3, that's now 3. So we now have 3 remainder. This remove 3 remainder 2. Okay? So these numbers that now leave remainders, they are not factors of the other numbers they are dividing. Okay? So they are not factors. Now, let's take some examples. What are the factors of 42? What are the factors of 42? So write the 42. Let's start with the smallest number, which is 2. So we'll start with the smallest number, which is 2. So 2 can divide 42. So 2 divided by 42, 2 into 4 will give us 2. 2 into 2 will give us 1. Now, at this point, let me explain something we need to understand. How do you know if a number is divisible by 2? You have to look at all the numbers individually. When you look at 4, can 2 divide it? Yes. Can 2 divide this? Yes. So it means that it's divisible by 2. Another way to do that is to look at the last number. Let's say you have 968. As long as the last number 2 can divide it, it means that the whole number is divisible by 2. Now for 3, how do you know if a number is divisible by 3? The easiest thing to do is to add all the digits of the number. let's say 42. It's 42 divisible by 3. Do 2 plus 4. It gives us 6. Is 6 divided by 3? Yes. So 42 is 3 is a factor. 3 can divide 42 without a remainder. 968, is it divisible by 3? How do you know? 9 plus 6 is 15. 15 plus 8 is what? 15 plus 8 is 23. Is 23 divisible by 3? No. So it can't go. And as long as 3 cannot divide it, all the multiples of 3, for example 6, 9, cannot also divide it. Okay, so I need you to understand this concept very well. Okay, so for now, let's go back to this. 42 divided, we're looking for the factors of 42. So 2 divided by 42, 2 into 42, it will give us 21. So can 2 divide this? No. But can 3 divide it? 2 plus 1 is 3. So 3 can divide it. To use 3 to divide this. 3 into 21 will give us 7. What else can divide this? 7. So 7 divides 7. I'll have 1. So the factors are 2, 3, and 7. Okay. Then also, one thing you also have to know that these also are called the prime factors. Okay, so we use only prime numbers to divide. So express, this is our second example, express 144 in prime factors. So 144, we'll start with the first prime factor, which is 2. Can 2 divide this? Look at this number. 2 can divide it. So 2 divided by this, 2 into 14 will give us 7. 2 into this 4 will give us 2. Can 2 still divide? Yes. 2 divided by this into 7 will give us 3. We'll carry 1 to this place. 2 into 12 will give us 6. 36. Can 2 divide it? Yes. 2 into 36. Don't forget, how do you know 2 can divide? Look at the last number. So 2 divided by 3, 1. We'll carry 1 to this. And that's 16. 16 into 2 will give us 18. Can 2 divide? Yes. So 2 will divide 18. That gives us 9. Can 2 divide? No. We'll go to the next prime number. And that is 3. 3 into 9 will give us 3. 3 also can divide. 3 into 3 will give us 1. So in prime factors, we now have 2 times 2 times 2 times 2 times 3 times 3. So we've now expressed 144 in prime factors. And that question goes this way: express 55 in prime factors. Can 2 divide this? No. Can 3 divide this? When you add, no. So the next prime factor is 5. Can 5 divide? Yes. So let's divide by 5. 5 will divide 55, give us 11. What else can divide? 11 can divide. So 11 into this will give us 1. So this in prime factors would now be 5 times 11. Alright, so now let's go to the next concept. And the next concept is highest common factor. So some questions, you see a question like this: find the highest common factor of 4 and 10. Now, what are highest common factors? The highest common factor, what can also express them as HCF. Highest common factor is the factor that is common between 2 or more numbers. The highest number that is common between 2 or more numbers. So the number is the highest that can divide these 2 numbers. Okay, so how do you do it? We'll find all the prime factors of the numbers. So for 4, we'll divide by 2, it gives us 2, and 2 dividing, we'll have 1. So 4 in prime factor will be 2 times 2. So 10, let's express 10. 2 into 10 will give us 5. The next thing I can do is 5. 5 divided by 5, 1. So 10 in prime factor is 10 equals 2 times 5. So the numbers that are common, 2 is common. So that's anything that is common here. So So the highest common factor will now be 2. Now let's take another example. Find the HCF of 18, 42, and 24. So 18 expressed in its prime factors, 18 will give us 2, we'll have 9, 3 here we'll have 3, 3 we'll have 1, so 18 equal to 2 times 3 times 3. What of 42? 42 will give us 2 here will give us 21, 3 will give us 7, and 7 will give us 1. So 42 equals 2 times 3 times 7. Now 24, let's express it. 24, 2 can go, 2 give us 21, 2 will give us 12, 2 again will give us 6, 2 again will give us 3, then 3 will go, so 24 will give us 2 times 2 times 2 times 3. So we'll now collect the common numbers, 2 here, then 3 also this way. So we'll have 2 times 3, which is 6. So 6 is the highest common factors. So 6 is the highest number that can divide this, and divide this without leaving any remainder. Now we'll look at another concept called the lowest common multiple, or LCM. Now when we say a multiple, we already said that before, a number that can divide another number without a remainder, it's said to be a multiple of that number. Let's say 72, 8 can divide 72, and that will give us 9. It won't have a remainder. So that means 72, 8 is a multiple of 72. Okay, because it divides it without a remainder. Now, but when you have series of numbers, let's say 3 different numbers, for example, 8, 9, and 12. We now want to find the lowest common multiple of these 3 numbers. Now, how we solve it is this. We'll put the numbers together, 8, 9, and 12, and divide all of them using prime numbers. So 2, dividing all of them, 2 into 8 will give us 4. You can't divide 9, so we'll bring 9 down. 2 into 12 will give us 6. Let us still divide by 2. 2 dividing 4 will give us 2. 2 divide this, we'll bring it down. 2 dividing 6 will give us 3. 2 can also still divide. 2 into this, 1, 9, and 3. What else can divide 3? 3. So here we have 3, we have 1 here. 3 can still divide. So the aim is to keep dividing to have 1, 1, 1 left. Then we'll now multiply these 3 numbers. So we'll have 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, then 24 times 3 will give us 72. So 72 is now said to be our lowest common multiple. Okay, let's try another example. Find the LCM, find the lowest common multiple of 15 and 33. Okay, so put it this way, 15 and 33. Can 2 divide both of them? No, 2 can't go, but 3 can go. 3 will divide 15, 5, and this 11. What else can go? 5, 1, 11. Next thing is 11, 1, and 1. So we'll now multiply this. 3 times 5 is 15. 15 times 11. 15 times 11 is what? Whenever I multiply by 11, add these 2 digits. 1 plus 5, 6. Then put them aside. Put the sum in between the numbers. So answer is 165. So 165 is our LCM. Let me explain. Whenever I'm multiplying a number by 11, a 2-digit number, as I told you before, for example, 62 times 11, add the two numbers, 6 plus 2 is 8, and put it in between. So our answer is 682. Another example, 54 times 11, 5 plus 4 is 9, so put it in between. So our answer is 594. It's as simple as that. Okay, let's take another example before we go to our next topic. And this is from Junior WAEC. It says, divide the LCM by the HCF of these numbers 6, 9, and 12. So first find the LCM. The LCM, don't forget how we'll do it. 6, 9, and 12. We'll put all of them together. 2 can divide. We'll have 3 here. 9 and 6. 2 can still go. 3, 9, and 3. Next 3 is 1, 3, and 1. And 3 can now go 1, 1, 1. So we'll now multiply this. 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is what? 36. As I always emphasize, please learn your multiplication table. This is the most important thing you can learn in mathematics. Now let's find the HCF. So for HCF, we will now take it individually. 6 we'll express in prime numbers, and that's 2 to go 3. 3 can divide 1. So 6 is 2 times 3. We'll do the same for 9. We divide by 3 gives us 3. We divide by 3 again, 1. So 9, the same thing as 3 times 3. We'll do another one for 12. 12, 2 can divide. 12 divided by 2 will give us 6. 2 can go again, 3. Then 3 can go. So 12 is the same thing as 2 times 2 times 3. So now find the numbers that are common. 2 is not common to all of them, but 3 is. So we'll take only 3. So our HCM is 3. Then our question says divide this by this. 36 divided by 3 will give us 12. So 12 is our final answer. Now click on Start Quiz and solve all the other examples.